Today we'll just overview the different modules and what is included there. I'll show you the course outcome. Let me share my screen. Are you able to see my screen?
Yes, sir. We can see it. Yes, sir.
Okay. So here you can see this is the lesson plan. Yesterday I have shown you the PPT in that 8 modules are there. So here if you see, this is the unit number and total 9 units are there. So in that yesterday's PPT I have not included this introduction part, which is not included in your syllabus. Actually your syllabus starts from PN junction, this one. Okay, so this introduction part is necessary, that's why it is included here in lesson plan. And including this one, this is 9 units, but actual topic is, or modules are 8 modules. Okay, so the first class means yesterday we have discussed about the marking scheme and all. Today we'll discuss the course outcome. Course outcome means once you cover these modules and this course, what you learn. Okay, what is the objective, and after finishing this modules, what you can able to do, that decide this course outcome. Okay, so you can see here this is the definition which is defined for this course. At the end of this course, the students will able to understand this CO1, CO2, CO3, CO4, CO5, CO6. That means 6 outcomes are there. And the first one, identify different diode circuits and analyze them. That means once you finish the first module, you will able to understand the diode concept, fundamental principle of diode circuits, and you can analyze the circuit. You can get the result of these circuits, everything you can able to do. Okay, so what is there? So this is the first module. But to understand this first module, we require a basic idea about the semiconductor and the different properties of semiconductor, how the semiconductor forms, what is extrinsic semiconductor, what is intrinsic semiconductor, and in extrinsic, what are the different types like N-type, P-type, why it is called as N-type, why it is called as P-type, which carriers are more in N-type, which carriers are more in P-type, then how the current will flow inside semiconductor, what type of biasing or what type of voltage we should apply. So these are the very basic fundamental things which you have already studied in +2 level. So that's why the course is not including this semiconductor, but I'll take few classes regarding that. I may take 3 to 4 class to explain you the semiconductor property, different type of semiconductor, then how we can distinguish between semiconductor, metal, and insulator, what are the different type of semiconductor properties, then current like drift current, diffusion current. So maybe 3 to 4 class I'll take that. Okay, which is not in your syllabus, but still, because this is the fundamental things, and without understanding or clear concept of that one, diode and further topics are very difficult to understand. So we'll just revise, and that's why this starting 3 to 4 class, 5 class is very, very important. Okay, here it is mentioned only 1 lecture, but I'll take 3 to 4 lecture. As I told you yesterday also, initially I'll very slow. Once the foundation is very strong, then we can go quickly. Okay, next in diode, these are the topics we'll cover. That means any topic which is included here will consider as a whole. Why the diode is like that, why it is called like so, and how we can form the diode, then what is the property, how we can operate the diode, what is the operation principle of diode. Then you can see diode characteristic is written here. Characteristic means it is the current versus relationship current and voltage, how we vary the voltage, maybe voltage positive or negative, or voltage is zero. In that conditions, how your current changes in the diode, that is the characteristic. Generally it is called as VI characteristic or IV characteristics. So once you understand that the relationship between current and voltage, that is the diode equation, and equivalent circuit. Equivalent circuit means you can understand in 12th standard you have studied KCL and KVL, and in that you may have seen different components. Okay, can you just identify or tell me what are the how many circuits you have solved in KCL, KVL to find out current and voltage and all? What are the things are present in that circuit? Whatever you have solved in +2 level. Can you recall that?
Inductance, conductance,
inductor,
resistance, conductance, resistance.
Conductance is not there. Conductance means the conductor. Inductor, capacitor, resistor, voltage source, current source, transformer. Yes or no? Dependent current source, independent current source, dependent voltage source, independent voltage source, DC source. All these things are present. Okay. And you're comfortable to analyze the circuit by applying KCL and KVL. Now, once we study this PN junction diode, it is having a symbol like inverted triangle horizontally, and one line that maybe you have seen. So, if the diode, one or more number of diodes are present in a circuit, then we may confuse what type of, how much current is flowing, how to analyze or how to put voltage across that. Okay, so that's why we can replace this diode with some known electrical components like voltage, resistance, all those things we can replace, so that the analysis or circuit analysis will be easier, because already we are comfortable with that resistor, inductor, capacitor portions which are present in the circuit. Okay, so that's why this diode is replaced by some equivalent circuit or equivalent circuit model. So we'll see that one, so that the circuit analysis will be easier. So once you have these conditions or these ideas very clear in your mind, what is a diode symbol, why it is called as like so, what is the operation principle, characteristic, equation, model, then we can go for application. Okay, so half-wave rectifier and full-wave rectifier already you have you may study in your +2 level, but again here it is included because these are the very fundamental application of diode. In half-wave rectifier, one diode is there, and full-wave rectifier, two type of circuits we'll see. One is bridge rectifier and another one is center tap. This is CT full-wave rectifier. Oh, this is PDF. Okay. So this center tap full-wave rectifier and bridge rectifier. Okay, we'll see that one. And the rectifier output is not pure DC, so that's why some filtering action will be taken place. So that filter circuits are included here, like capacitive filter, inductive filter, LC filter, pi filter. So we'll see when you go for this rectifier circuits. Then another application of these diodes are clipper and clamper. Basically, we require KCL and KVL knowledge to solve this clipper and clamper. One circuit will be given and input will be given. You have to analyze the circuit, apply KCL and KVL, and what is the output, you can test that one. Okay, so that completes your whole diode topic with application. Next is breakdown mechanism. Means if you increase the diode voltage in reverse bias, even third bias, more and more, then at some point of time the heavy current will flow and it will break down. So why that breaking down happens, that mechanism we'll discuss. And related to that, another diode is there which is called as Zener Diode, and we'll see what is the purpose of Zener Diode and application of Zener Diode as voltage regulator. So that the foundation of basic foundation of diode will complete here in module 1. Once it completes, you can understand, you can see CO what is defined, that is fulfilled. Identify different means at the end of the course, the student will able to identify different diode circuits and analyze them. Okay, is it clear?
Yes, sir.
Yes, sir. Yes, sir.
Now, once you have an idea of PN junction diode, then we'll go for transistor. So transistor, two type of transistor basically we will use, PNP transistor and NPN transistor, and it is very much related to diode concept. You can see PNP transistor means one PN junction is there, and if you look at from this side, another PN junction is there. So two PN junction are connected back to back to form a transistor conceptually, and if you understand the diode concept, you can easily understand the transistor concept. So transistor main function is amplification. Can anybody explain what do you mean by amplification? Do you know? Amplifier. Here
Yes,
about
it
the amplifier.
was the whatever unit the it increases the power or output of increasing of the magnitude of a variable.
Amplifier means it will amplify the signal strength. Okay, signal strength means amplitude, but it will not change frequency. Okay, so frequency means suppose I am talking here, I am having a fixed frequency. So in amplifier, if frequency changes, then signal will deteriorate or signal will change. That's why frequency remaining constant, the amplitude will increase, because whenever the signal will travel through a longer distance, the amplitude will decrease or it will lose its strength or energy. Even if a louder voice, if you go to a field or open space and sound with your maximum power or maximum energy, it can travel maybe 100 meter, 200 meter or 500 meter. Okay, that means the signal while traveling through distance, it radiates or it loses its energy and it is not audible to after some distance. So when we like I'm here and you are at a far distance, like maybe 100 kilometer, 200 kilometer, 500 kilometer maybe, so it is not possible to transfer my signal, my voice signal to you without amplification. Okay, so that's why this amplification is required, and contribution of transistor is immense here. Without transistor, this amplification is not fulfilled, okay, or not possible, I can say. So whatever in the field of communication is developed last 50 years or 70 years, 1947 this transistor is developed. So after that, huge change in the communication field, okay, and that is due to this transistor. Transistor, I mean, this is the preliminary thing, and now a lot of things are here. Also, we'll see BJT, then JFET means this is also another type of transistor. Junction Felipe transistor, MOSFET. This is another type of transistor. Okay, so though the drawbacks of basic preliminary transistor is improved, but the transistor remains same and fundamental principle remains same. So we'll see type of transistor, then what are the different type of currents which are flowing through the transistor, then operation of transistor, and different configurations, common emitter, common base, common collector, characteristics, then what are the relationship between current gain, alpha, beta, gamma. Alpha is related to common base, beta is related to common emitter, gamma is related to common collector. We'll see, and after that we'll see biasing. Biasing is nothing but applying the voltage to the transistor amplifier circuit and proper choosing of resistance, capacitance, but the other components are present in that amplifier. How we choose that one, and so that the amplification purpose will be fulfilled. Okay, when as a designer, when you design, everything should be found in perfect place. The component values, supply voltage, everything should be fixed, depend upon your requirement. Like you can see, suppose I'll try to design an amplifier which will give you gain of 100. That means output by input value should be 100. When I am giving 1 millivolt of signal at the input, I should get 100 millivolt at the output. So that 100 millivolt is output divided by 1 millivolt input, gain should be 100. So what type of, how much value of resistance I'll keep, what is the capacitance value I'll take, what is the, which type of transistor I should take, and how much supply voltage I should give, everything should be calculated, and so that gain will be, your requirement gain will be fulfilled. So that is biasing, Q point and load line, everything is including here, that process. So we'll discuss that one. So after finishing this transistor topic or module 2, we can say the student will able to understand the working of BJT in different modes, configurations and biasing circuits. Okay, this is the objective of your course. Next, what it is there, junction field effect transistor and MOSFET. So basically some of the drawbacks of the transistor is overcome by this JFET. Full form is junction field effect transistor. And here also we'll see the operation of P channel and N channel, two type of JFETs are there, and characteristic of JFET. So what is the difference between this PNP transistor, NPN transistor and JFET we'll see, and how it is improved from the transistor we'll see. Again here, what is the drawback in JFET and how to improve that one using MOSFET is the next topic, and its operation type and characteristic, everything is included here. And application of MOSFET, here it is included as Cmos inverter. So inverter means nothing but NOT gate. Okay, you might be studied this and logic gates, AND gate, NOR gate, NOT gate, XOR gate, NAND gate. Okay, so out of that NOT gate, if you consider, when whatever value you will give at the input, output will be inverted of that one. If you give 1 at the input, output will be 0. If you give 0 at the input, output will be 1. So basically that is inverting the input signal, and using MOSFET, we can design this inverter, because when you have studied this logic gates, you are only able to see the symbol, but inside that some circuitry is there, and we can use this MOSFET to design this CMOS inverter. CMOS means complementary MOS. One N-channel MOSFET and one P-channel MOSFET will be combined together to design this CMOS inverter. We'll see when we go for this one. So once you complete this module 3, you can able to understand working of JFET, MOSFET and CMOS inverter. Clear?
Yes, sir.
Yes, sir.
Now again we'll go to amplifier, means like I told you, diode equivalent circuit. Here BJT equivalent circuit also will study. That means when you design any amplifier, what the components are present and how you can analyze the amplifier, how you can replace the transistor with resistor and a voltage source. That is the RE model. And here RC coupled amplifier BJT to calculate means we'll design an amplifier, and for that we'll calculate gain, input impedance, output impedance of that circuit, and how the gain will change with respect to frequency, cutoff frequency, bandwidth, everything is will be in this module 5. Okay. So module 4. So here you can understand the working of BJT amplifier and analyze using the small signal model. After that, module 5 and 6 include your feedback and power amplifier. So feedback means basically in day-to-day life we are observing this feedback concept. Whenever like you are traveling to somewhere with in the train, or if you are going for any vacation somewhere you are staying, so when you are using that service, after this the company or the persons who are giving you service, they require feedback. Even here also, every day after the class, you can see in the SAP portal, you will see a feedback topic or feedback module, where you can give the feedback of classes. Why these feedbacks are taken? Actually, if you analyze the fundamental principle, suppose you are going through a train, and the catering service or the cleanliness service, they are asking for giving some paper and asking for feedback. So after taking those feedbacks, whether it is the train is clean or catering service is good or not, or how to improve that one, you will give some suggestions, and those suggestions will be given to the service provider, and those service provider will take those things and try to improve their performance. Maybe in reality it is not happening or happening, that I don't know, but the concept is like that. But in electronic circuit, the same concept will be played here. Suppose we are designing one amplifier, and we see my target is 100, as I told you in previous example. Suppose I try to design an amplifier whose gain should be 100, and during the design process, whatever calculated I have done, calculation I have done, and resistance, capacitance, all those things, values I have calculated, supply voltage, and I have implemented that one, and I have seen my gain is 80. Okay, so there is some mismatch of my target and what I have achieved. So these performance or these indicators will be again evaluated, and those things will be given through a feedback loop, and so that the performance can be improved. Okay, in that way it is used. I can explain in a brief. So there are different type of topology, different type of feedbacks are there. We'll see that one. And one very important concept, whenever we try to generate one oscillating circuit or oscillating output like sine wave, cos wave, or square wave, all are AC things. So to design those things, we require these feedback, positive feedback, and those circuits are RC oscillator, AC oscillator, we'll see, and we can also calculate the frequency of oscillation of those circuits. So this is the feedback, and after that we'll see the power amplifier. What are the different type of power amplifier? Class A, Class B, Class C, and push-pull amplifier, we'll see. So that gives the CO5. Understand the requirement and application of negative and positive feedback in the electronic circuit. Identify different types of feedback. Power amplifier, identifying different types of power amplifier. Okay, that is the CO5. Next is module 7, 8 actually 7. So here we'll see different operational amplifier configurations. Operational amplifier means like we are using for some calculation, like if you give some numbers and try to manipulate it by adding or subtracting, or you can take log of that value, or if you take any sine function or cosine function, any function, exponential function, and trying to differentiate it and integrate it, so we'll get some value, and mathematics will be easy. So if you compare these things with signal processing, whenever you are taking some signal, then that will be also manipulated or processing requirement. So here also we can add two signals, or difference two signal, or integrate one signal. Like if I ask you sine function integration, you know, differentiation, you know, but while we are dealing with this communication systems and mathematical to real life signal system processings, then you require to integrate, differentiate all those things. So mathematical operations are required. So using this operational amplifier, it is possible. So that's why it is called as operational amplifier, and operational short form is OP, amplifier short form is AMP. So in that way, it is combined to give a short name op-amp, OP, AMP, op-amp. Okay. And the applications like summing amplifier, differential amplifier, integrator, differentiator, inverting, non-inverting, unit gain, buffer, all these things are there, and including that one, the basic fundamental principle of op-amp, characteristics, circuit, everything is included here. After that, some instrumentation amplifier is added, and comparator, Smith trigger. So what is the function of this comparator? Is very useful in day-to-day life. Suppose I'll take a circuit and try to compare the things. Suppose in general I'll take some threshold value of temperature, let us say 30 degree or 35 degree. Okay, in summer season we are going up to 40 degree. Let's say room temperature is 30 degree, and I can tolerate the temperature up to maybe 32 or 33. And then after that, I can use my AC to switch on. So I can give one comparator there. So threshold set will be 32 or 33 degree. If the room temperature will beyond that value, then it will give you one logic signal, maybe 1, and it is directed to LED so that light will glow. I can indicate this temperature is increasing after the threshold voltage, and if it is less than that, it will give you 0, so signal will be off. So this is a very real example of this comparator, which we can obviously there are a lot of applications we can go for that, but this is the basic example what I can give you. And Smith trigger is another circuit which can generate pulse wave or square wave. Even a 555 timer also a circuit which can generate the pulse. Pulse means train of pulse or square wave. So there are different patterns like different combinations, astable, monostable, multivibrators are there. And this is a IC actually integrated circuit where inside that integrated circuit, lot of components are integrated like transistor, resistor, capacitor, comparator, okay, then inverter. Okay, all these things are combined to make a structure or a club, and that can be used for generating different signals. Okay, and that decide this 555 timer and its modes. Modes means astable or monostable multivibrator we see. And VCO PLL generally used in communication circuit. VCO means voltage controlled oscillator, and PLL means phase locked loop. Okay, so if you look at the CO, understanding the working and application of different ICs. ICs means this operational amplifier is also come in the form of IC. Its name is LM741. If you see the IC, then some numbering is there, and from that number you can understand which purpose is IC and which is used for which action. So these different ICs means including op-amp, operational amplifier I told you, and timer, 555 timer, and VCO. So all these things we'll understand in CO6. So once you cover all these COs, then student can understand the basics of electronics, which will be useful in their life. And books are written here. I'll upload this one in classroom, and including that some day-wise lesson plan is prepared by the course coordinator. That means each day what will cover. Maybe little bit differ will individual to individual. Like first class we have introduction, and second class today second class, that is course outcome. Third class directly it is written PN junction diode and characteristic, but before that this day 3 portion I'll take in between 3 to 4 class, so that you will comfortable to understand the PN junction diode. Likewise it is breakup, and you can see after first module assignment 1 will be given, and before midsem we have to cover up to BJT. So after that completion of BJT we'll take quiz 1, and after midsem we'll cover this BJT model and all. Then I'll give activity in advance, maybe 1 month before the end sem, so that you can have enough time to prepare the activity. Then towards the end of the 7th module we'll give assignment 2, and at the end of the whole syllabus we'll take the quiz test 2. Okay, so that is mentioned, and I'll upload this one. A little bit here and there will be there, but we have to complete the finish. We have to finish the syllabus within 40 or 42 class, so that will be good. And what else? So this number of lecture and all are written, so including all these things it is mentioned to 40, but maybe it is little bit here and there, maybe sometime like these two combinations all are mathematical equations, derivations. I may take here 3 classes written, I'll take 1 class. I can cover all these things in 1 class. Okay, so we can make up all these things. If we have this fundamental knowledge very strong, then we can proceed for that. So that's it from my side of course discussion. If you have any doubt regarding this, you can ask me now. "88 students have joined," right? So because we have not discussed anything, so I'm just giving a brief introduction of the subject. Don't think that all these things are there and how you can cover. Don't burden yourself. That's why generally in elaborate thing I'm not telling here, so that it will feel little bit complex thing. Very simple way. Once we proceed further, then we can able to understand everything. If having any question, you can ask me. Any doubt regarding the course and topics and all?
No, sir, no doubt. So it was just the introduction.
And just introduction means overview of the topic. Next class means tomorrow we'll start the topic, and we'll start from atom various class. So don't miss the class. At least this new starting 4 to 5 class where fundamental things will be taught. So you should because in 12th standard you may study that one and little bit things which is very useful. So 88 students are there, 92 or 94 strength is there. So those who are missing the class, you just inform them to join if you have an idea. That's it. So we can stop for today.
Okay, sir. Thank you, sir.
Thank you, sir. So tomorrow
Thank you,
class
sir.
5 to 6, right?
Yes, sir.
Again, we'll meet on tomorrow 5 to 6.
Thank you, sir.
Okay, sir.